Hey everyone, thank you for joining for my session today. I'm going to talk to you about how we could use DAPR, which is like a really lightweight runtime for building microservices, how you could add some of those components to your .NET applications. We've had a lot of conversations about what microservices are and what we can do with them. So what I want to show is how DAPR could actually make the development of those things a little bit easier for you. All right, so let's start off with talking a little bit about why is building microservices so difficult? Right? I feel like the ecosystem is really rich with a lot of different tools and services and different frameworks that we could leverage. But I also feel like some frameworks versus the others might have a little bit more support, right? Like some frameworks might have better support for messaging or for using open telemetry and distributed tracing and those types of things. And also, some of the frameworks might not necessarily support the targeted framework or the targeted OS that you're trying to deploy to. Right, so maybe some of them are more Linux focused or Windows focused, or maybe they're focused on deploying to Kubernetes versus maybe you just want to run your own VMs, right? And so depending on what you want to use, you kind of have to filter out and determine what are going to be some of the best components that you could use to kind of plug together and make that world kind of work for you. And so this is where DAPR comes in, right? This DAPR is a distributed runtime, and this is DAPR, right? And what it allows you to do is to abstract some of those concerns, some of those commonalities that we use for building microservices, and it makes it very easy for you to kind of just add them to your application as needed without having to worry too much about where the things are and how do I set them up and those types of things. It kind of just makes building these apps a little bit easier. So let's talk about really quickly, what are some of the main goals of DAPR? Right, so first of all, we're going to see that an important thing is that it supports a lot of different languages and frameworks. So, I know we're at .NET Conf, and I'm definitely going to show you some .NET demos. But if you're building an application that runs with maybe like a mix of different programming languages, maybe it uses like Go and it uses Python, uses PHP or something of that sort. How can we plug all of these things together and still use the same type of tool set to be able to build our distributed application? It actually reminds me of a story about, a few years ago, I used to actually build stock trading software. And, in that company, it was actually like a mix of a lot of other smaller companies that it had acquired over time through acquisitions. So that meant that its development team was a development team that was a mix of different tools and frameworks and stuff like that. So that means that some of the folks were writing Ruby and some of them were writing Python. And, I was doing .NET, right? So now, how is it that we're going to be able to leverage all these different tools and different libraries and different parts of the larger application that are all built in these different types of languages and platforms, right? And so, we had to do some gymnastics to get around that, but now we have DAPR, and hopefully that can make that a little bit easier for us. DAPR also adopts a lot of open standards, so you'll probably hear folks talk about things like cloud events, things like open telemetry and those types of things. By adapting those open standards, it makes it a lot easier for us to integrate with existing tools and services. Maybe you want to use something like Zipkin, or you want to use AMQP for messaging and those types of things. And then DAPR is also very extensible and pluggable. So depending on whatever target it is that you're trying to get to, maybe you want to use Redis or some other cache, or you want to use something like Cosmos DB in the cloud, right? It has a very pluggable architecture that if you wanted to use those things, I could very quickly pull them in and make those work. And so this is kind of what what DAPR kind of looks like, right? I mentioned at the bottom, it supports a lot of different building blocks. So DAPR itself allows you to use things like service-to-service communication, it allows you to use state management, public subscribe functionalities, and all your application at the top needs to do is to be able to speak HTTP or even gRPC. So as you can see at the top, regardless of whether I'm writing Node or Python or .NET Core, I could be able to communicate with that DAPR runtime to be able to leverage some of these additional functionalities. So what does that mean? Well, I don't necessarily have to bring in any additional NuGet packages. I don't have to rely on anything other than what's exposed by your DAPR. And if you notice at the bottom too, it also shows that we could deploy this almost anywhere. Now I'm going to show you some demos of this running locally on my machine, but I could very easily deploy this to Azure. I could run this in AKS and have it running in Kubernetes. And I should be able to have the same type of application architecture, the same type of experience, regardless of whether I'm running in the cloud or I'm running on my own infrastructure. So how does DAPR do this exactly? Well, DAPR makes use of something called the sidecar pattern. right? And so if you're not familiar with that pattern, essentially next to your application, and if you see these little gray boxes that are here, that represents your app, right? So your application is going to rely on this sidecar, right? It's a DAPR process that's going to be running locally right next to your machine. So again, if we're talking about Kubernetes, it's going to be running within the same pod. Or if you're just talking about a virtual machine, it'll just be running right next to you on localhost. But now your application is going to primarily focus on communicating with that DAPR sidecar. And then now those other sidecars that are attached to those other instances of your apps or services across the network are going to be able to talk to each other. And they're going to know, well, what services are available within my cluster? What kinds of functionality do I have enabled? So, hey, do I want to do pub sub with, a component? Then my app doesn't need to know where that pub sub component is. It doesn't need to know how it's configured. All it needs to do is say, hey, DAPR, here's a request. I want you to go do this work for me. And could you please let me know when it's done and send me back the request? And then DAPR, based on its configuration, is going to go ahead and figure that stuff out. I mentioned a little bit earlier that we could host these inside of Kubernetes. The DAPR team has Helm charts and all kinds of stuff that's in there that allow you to do pod injection. So as you're deploying your application, it'll just insert that DAPR container, right? It'll insert that DAPR sidecar process inside of your pod for you. So now, again, your application will just be speaking to it, just like it's speaking to something that's running on localhost. All right, so let's kind of dive into these building blocks. And I want to show you a couple examples of how exactly DAPR does, some of the things that it actually does. Right, particularly today, I want to focus on the service-to-service invocation. We're going to look at state management, pub sub, and then hopefully if we have some time, I'll show you what some of the distributed tracing features kind of look like. All right, so let's talk about service-to-service invocation. Now, when you have a distributed application, you might have one or multiple instances of a particular service. And the hard part is to know, well, where exactly does that service live? Particularly if you're talking about the world of containers, where these things spin up and spin down very quickly, you're going to have multiples of these things with different IP addresses and different port numbers and these types of things. Okay? Well, what DAPR does is that it exposes your different services once they're configured via a well-known URL pretty much pattern. Right? So if you notice here, my front end can speak to my shopping cart without really knowing where the shopping cart is. And it simply has to send a message over to DAPR and say, hey, I want you to invoke the checkout method on the cart. And you can kind of see that convention a little bit when you take a look at the URL. It passes along a payload, and then the two DAPR sidecars will, again, figure out, well, hey, do we have something that could understand this request? And then it'll pass it over to the right process that's going to be able to handle that. And then it'll send a response back. But from perspective of your application, you're just making a request. You know what I mean? And you got to get a request response. It's going to look like you're making a regular web service call. And again, I'm showing this here as we're using HTTP, but this also works if you use gRPC as well. Another thing you might want to do is leverage something like a cache or a key value store for doing some state management. And DAPR has, again, a well-defined endpoints too that you can make use of to leverage those things. So if you notice here, I can make a post request over to something on the port of /state/ and the name of the store, whatever my state store configured happens to be. And I can pass it over with a payload. And then it is stored inside of whatever was configured on the other side to store that information. So if you notice here, we could support Cosmos DB or Redis. We could support Cassandra and Cosmos DB and tons of other things. Now, why don't we stop for a second? I'm going to head over to Visual Studio Code. And I actually want to show you a demo a little bit of how some of this things gets wired up. So I'm going to head over to my browser really quickly. And hopefully you can see my browser right now. I'm showing an instance of an application called Contosocrass. Now, this was put together by my buddies, Brady Gaster, and I think Maria Nagaga also kind of worked on this application. And it's actually pretty straightforward app. It's only a single page. It's built on server-side Blazor. And what this app allows you to do is, well, I could view, some information about some items that are in the store. I can add them to my shopping cart. I can hit these add buttons. And then if I wanted to, I can hit this little shopping cart that's at the top. It shows me this checkout, and I can do some bit, right? And that's it. There's no other pages to the app, a single page application using server-side Blazor. But what I've done is I've taken this simple application and I've microserviced it a little bit, right? Like I've added some additional components to it. Before I go on, I just want to say might not necessarily be the type of app that you want to turn into a microservice, break it up into a microservice application. But I wanted to do this because I think it was, a simple enough application that, we didn't have to worry about too many moving parts. But the way that this is set up right now is that I have my front end application right now. So that's just my Blazor app and it's serving the UI, right? I have another web API that's another service that's running. And that essentially is communicating with the database. And, I'm making calls to that to get data and update things and so on in our data store. And then the third service I have is I actually have a queue processor. So every time I add something to the cart, right, and I come here and I hit checkout, what that's doing is it's putting an item onto a message queue. And then, I have another service that's listening to that queue for messages. And so whenever that pops up, whenever a message pops up in the queue, then my worker will start and will start processing. Okay, so let's take a look and see how we configured all this stuff inside of DAPR. Right? Now, first thing I did, I'm running a lot of this stuff inside of a Docker Compose file. So what you'll probably notice is I'll have here, if you're unfamiliar with Docker Compose, I'm defining a service. And this is just my .NET application, and it's running on port 80 and port 443 because I have HTTPS set up for it. But then I have my website, but I also have a DAPR sidecar running next to it, right? And my DAPR sidecar is just running this command, right? And then we don't need to pay attention to the rest of this, but as you scroll down, you'll notice that I have a products API, I have a checkout processor, but for each one of my applications, I have an associated sidecar, right? So there's a website and there's a website sidecar. There's a products API, and there's a products API sidecar. There's a checkout processor and there's a checkout processor sidecar. Because again, the whole point is that on my applications, they're going to speak to those sidecars, and then the sidecars are going to talk to each other. It's going to figure out where things are. Now, the only other thing that I needed to do in terms of me like configuring services and things of that nature is here, if you notice on my right side, I have a folder called components. And inside of my components folder, I'm able to set up a lot of different things that I want DAPR to use. So here, I'll give an example. Here's an example of my state store. So I'm saying here, I want to create a component called a state store. I want to use Redis, and here's where my Redis instance lives, right? So here you can see that I have a Redis service, and then there's a username and password. Well, there's just a password, and I'm getting that from a local secret store, right? And I kind of like that too, because that means that my secrets aren't exposed and everyone doesn't need to, see what I'm doing there, right? But that's all I have to do. And so now whenever I start up my process, DAPR is going to scan that components folder, and it's going to say, hey, what are the things that you have set up here? I'm going to wire them up for you. So now whenever I configure something to do state, or whenever I need a service, like it'll just find it, and then I'll be able to start working with it. Okay, we're going to talk about some other things too before I dig any more deeper into some of the DAPR stuff. Let's talk about PubSub, right? So a common integration pattern for a lot of folks is doing messaging with publish subscribe. So that means that I have some work that I want to have done, and I want it to be done in another process, or I want it to not run in a background thread in my app. I want it to run somewhere else. And so what I'll do is I'll put a message on a queue, or I'll use a messaging service again, I could use Event Hubs or Nats, or in this case too, you can also see that there's Redis here. And all I have to do is, again, I'm going to use that well-defined Docker endpoint. I'm going to make a request there, and then DAPR is going to know where exactly it needs to send that stuff. On top of that too, more recently, the DAPR team also added the ability for you to do input and output triggers. So essentially what that means is as things happen outside of your DAPR application or your DAPR-enabled application, like something might happen in Kafka or Event Hubs or something like that, that will now invoke your application and have it start running code. So again, instead of me just writing an application and me having a web front end, this can react to things that are happening on the outside. And very similar to, we also have output triggers too. So again, if you want to interact with another store or some other system outside of your application, we could do this as well. So that might be sending messages over to Twilio, or I might be running something on DynamoDB, or something like that. Okay. Now, let's do the PubSub demo, because this is the one I really wanted to show you, because there's a lot of cool stuff in it. Now, I am going to, so my app is still running, right? And I remember what I said to you before, right? Like, so every time I add something to the cart, I'm gonna click this thing. And what it's doing is that it's gonna send a message over to like our message bus. Now, in this application, I actually have RabbitMQ set up as my message bus, right? So you can see here, I have, my RabbitMQ connection string. I have some data here set up. But now that's all I really have to do. Like my application, my .NET code knows nothing about Redis. It knows nothing about RabbitMQ. And I'll even show that to you inside of the RabbitMQ management console. Right? So if you click here, you can see that I have connections here to 3 different services, which kind of makes sense, right? Because I have my website, I have my API, my queue processor. But they are all aware of what those things are, right? But they're aware because DAPR set that up for me and not because I knew anything about it. Also, you'll notice that I have an exchange here. I have an exchange called checkout. I also have a queue called checkout processor, right? Again, I didn't create these things. These are things that DAPR just made for me, right? And now my application can just use them. Now, just to prove the point that I actually don't need to change my application when I want to switch components, this is what I'm going to do. I have this RabbitMQ item here. I'm going to delete it. So I'm going to right-click. I'm going to delete it. Poof, it's gone. Don't have it anymore, right? But now, how is my application going to keep running, right? Like, how does it know, like, what is it going to use? Well, I actually have another PubSub component set up here. I have Redis also set up as a PubSub messenger. So, but what do I have to do to my code to actually get that to run now? Well, I'm just going to go ahead and I'm going to do a Docker compose as soon as my window comes back and lets me do it. I'm going to do a Docker compose up, right? So all I did was like I shut down my application and then I ran it again, right? So now my DAPR compose, my Docker is running. My DAPR doesn't know anything about RabbitMQ anymore because I took it out, but it does know about Redis. And you notice here, when I search through the logs, it says component found, message bus. It says Redis, right? So I'm like, okay, it is established that Redis is now going to be my message bus. So what does that mean? That means that if I refresh my application, right, and there's nothing in the cart, I'm going to add stuff to the cart again. Notice I haven't changed any code. I'm going to submit my application, and it's still working, right? And if I take a look at my logs at the bottom, I don't know if you could see this, hopefully you can. It says at the bottom, order received. So that's perfect. Like my app is still running. I've just switched out the component that I'm using, right? I've just switched from RabbitMQ to Redis, and I haven't changed any code, which is great. Now, some of the other things that come out of the box with DAPR that I think are really cool is it supports the Open Telemetry standard. So that's a standard where we collect our logs, our metrics, our tracing in a very uniform way. But because of that, DAPR knows how to do things like create, it knows how to actually find out what exactly was happening in our application if we wanted to. So here I'm using a tool called Jaeger. And Jaeger is a tool, again, like it displays traces and it collects that information for you. I can click on one of these traces and I can show you that, hey, our request was made, and it involved my website and the checkout processor, right? I could see how long it spends in my website, and I could see how much longer it spends in the checkout processor, right? But I could look at these things, and I could look at the different requests that were made. Let's look at one that called the shopping cart, right? So this is the shopping cart one, and is there anyone that's any more interesting? Right, here's one that called the products API, right? So here it called the products API, and it was waiting for it. This entire time it's here at the top waiting for it. And then when it got a response, it was able to continue and process. Right, so I could look at my requests and I could see where they're going and how things are happening. But also what's really cool is that I could click this system architecture diagram. And notice now just by the fact that I have Jaeger wired up, it can show me the components that are inside of my app. And remember I told you I had 3 components, right? I had this website, I had a products API, and I had this checkout processor. And now because I have Zipkin wired up and it's collecting these things for me, it's able to do that, which I think is really cool. Now, the last thing I want to show you, like at least in terms of the demo, is, well, hey, we have all these components that are running, but what if I actually wanted to debug these things? And I think being able to, have that developer loop where I can actually debug my running containers is actually really important. So what I'm going to do, so this is the code for my checkout processor, right? And all it does is that it just listens for something on a /checkout endpoint. I'm going to add a breakpoint here, and then inside of VS Code, I have a task set up that allow me to attach to the container. So what I'm seeing here is a list of different containers that are running. I'm going to select my checkout processor. Now, what I'm expecting to happen is that it's going to fire up the debugger, it's going to attach to the container, and now if I go ahead and continue using my app just as I was before, right? So again, I'm gonna click some things, I'm going to add it to the cart, I'm going to hit submit. 1, 2, 3, 4, 5, boom, there we go. And if you notice, it's now engaged my debugger, right? And I could step through the code. And again, this is running in the container using DAPR sidecars. And so if you want to really see what's happening in your app, you could set these breakpoints, you could debug through your app, and a very familiar development experience for a lot of us .NET developers. And if you notice here at the bottom too, it says information order received, so which I think that's great. Okay. All right, let's head back to the slides really quickly. I know we're running a little bit late on time. I only have like 30 minutes, so let's kind of scoop through some stuff real quick. All right, so that was DAPR, right? We have a lot of different components that are inside of DAPR that we could use. We saw service invocation, we saw state, we saw distributed tracing, we saw the pub sub stuff, and there's a lot more things that are inside there as well. Some of the things that we could start looking forward to in the future is everything that I've done so far has only been using like HTTP calls. The team's going to be working on a set of language SDKs that you could use. And also, too, there's going to be additional framework integration. So if you want to use things like Azure Functions and Logic Apps, or if you're a Spring Boot person, if you want to use that, or actors, you'll have that ability there as well, right? So right now, if you head over to the DAPR repo on GitHub, you'll see there's a project there that talks about integration with DAPR and Azure Functions. And I know them and the Functions team work together on creating these different input-output bindings for functions so you can use it with DAPR, which I think are really cool. One of the more newer projects is DAPR Workflows, which essentially is the Logix apps runtime, right? So the same Logic apps that we have in Azure today running within the context of DAPR. So if you have workflows that you want to orchestrate, you can have that running, but within your DAPR architecture and trigger there as well. There's also support for actors if folks are interested in that type of stuff. We just had to talk a little bit about Orleans, right? And so, you see a lot of games like Halo and those things are built on like an actor-based type architecture. If you're doing anything with IoT, that's another good example too of using actors. All right, so roadmap, really quickly. So what are some of the things that we got to look forward to? The team is working hard, pushing to DAPR 1.0. Then, we got to get the functions extension to 1.0, the Logic App extension to 1.0. And then hopefully, too, we'll see some work being done with getting DAPR into some of our managed services like Azure App Service and Azure Functions and things like that. But I think that's all I have to show you for now. I know I'm running super late on time. I want to leave some time at the end here for some questions. But if you want to learn a little bit more about some of the things that you've seen today, definitely go check out this website, theurls.com. I promise it's a safe link. You don't have to worry about it. But you head to theurls.com/.net-dapr, and I'll have a collection of links with the source code for the demos, links to the Gitter community for DAPR. Definitely go in and check out some of the issues, look at some of the things that they're working on, and and see if maybe DAPR is a good fit for your application that you're building. And if you have any questions, let me know. I can't hear you, Javier, if you're speaking. Can't hear you.
How about now? Can you hear me okay?
Gotcha.
Perfect.
There you go. I was like, am I talking to myself? Like,
I've been having issues with my mic all day. I've been checking everything, and I was trying to get the next speakers up and going. Anyway, so we have a few questions out there.
Sure.
So from George Stocker, he asked, so to me, someone who never really adopted these frameworks, do DAPR, Orleans, and Steel Toe all try to solve the same problem?
Yes or no. I think they saw them using different ways. So first of all, like Steel Toe, for instance, is a package, right? So that's a NuGet package that you run in your .NET applications. Mm-hmm. DAPR is not a package, it's a runtime. So that means that it's a process that you're actually going to run on your machines, on your servers, on your containers, whatever the case is. And it's also language agnostic. So it doesn't have to be a .NET application, or it doesn't have to be any application that's based on one programming language. Again, like I think a lot of folks, particularly in the enterprise, are using multiple things when they build up their solutions. And so if you want to pick and choose what you want to use, it's okay, right? Like all you have to do is be able to speak HTTP or gRPC, and it'll work great.
Yep, perfect. So let me go to the next question. So does DAPR allow HTTP or only gRPC? I've had issues using the DAPR/.NET SDK.
Yeah, it allows both. I personally have not used the .NET SDK, mainly because I think the RESTful endpoints have been plenty for me.
Yeah.
But if you're having issues with that, I definitely recommend you to go ahead and file an issue inside of the Git repo. I know folks are constantly looking at that and looking for feedback. And so if there's a mismatch there between, what your expectations are, I definitely say to do that.
Perfect. All right. So here's another one from our Adam or rerun Adam. Since DAPR is defining an abstract version of a message bus in the example, Redis and RabbitMQ, how do you handle the fact that RabbitMQ and Redis offer a different set of features?
Sure. So I think what you're seeing with DAPR is they're giving you their prescribed patterns, right? So what does that mean? So sure, you can do a lot of things with RabbitMQ. You could do fan outs. You could do competing consumers and lots of different types of patterns. I know Redis has a streaming feature, which is there as well. But what DAPR is doing is that it's just trying to abstract the common pieces of building microservices, right? So what are those common pieces? There's never going to be, I support everything for every different target kind of thing. You're going to have to kind of pick and choose and see what makes the most sense for your application. Maybe you have a DAPR application and you don't use those features, but maybe you just make use of the observability features because you want to get that app map functionality, or maybe you just want something to, kind of do secrets for you. Like that's possible as well. But if you do need those more advanced features, then, maybe you do need to just commit to using that product's SDK or, their API or whatever the case is, and take it from that approach.
Excellent. Let's do one more question.
Sure.
All right. So let's see. From Andy Wall, which I think we kind of answered it. What is the difference on positioning between Steel Toe, Azure Service Fabric, and DAPR?
Yeah, they're just different, right? So again, Steel Toe is it's a package. It's a .NET package. With Steel Toe, you still need other stuff, right? Like DAPR is a runtime and it's something you communicate with. Steel Toe, for instance, like if you want to do service discovery with Steel Toe, like I still have to set up console or Kubernetes or whatever the case is, right? And then, I'd have to be writing my code to focus on that thing, right? Versus DAPR, one, like it just kind of does it for me, right? Like a lot of those things are ambient. And so my application knows a lot less in terms of like code I have to write and packages I have to depend on. Again, even like things like, what'd you say, Service Fabric? Like for Service Fabric too, like that's a service that runs in a cloud. Again, DAPR, you can run it anywhere. So again, like there's different ways to do things. I think, just as you have to make the decision about whether I want to build a microservice or not, like you have to kind of determine, well, what are the features that I really need for my application or not, and then make those smart choices.
No, that's really great point. Well, I think that's it. We're right on time. Cecil, thank you so much for taking the time to print us. It was great. I know you and I went through an A/B check, and you showed me all the demo, and I can't wait to take a look at it and everything. Thank you so much for volunteering your time. We'll be right back more with .NET Conf focus on microservices.